You know, our world is officially wireless. I mean, think about it. From the smart speaker in your kitchen to the critical sensors in a hospital, we have billions of devices online right now. But have you ever stopped to wonder how it all actually works? And maybe more importantly, how do we keep it all from falling apart? Well, in this explainer, we're going to break down the four big pillars of this modern wireless world: the absolute explosion of IoT, the security that has to protect it, the design that makes it reliable, and the automation that's starting to run the whole show. So here's our game plan. First, we'll get a handle on the incredible scale of the Internet of Things. Then, we are going to dive into the really critical question of how to secure this gigantic new landscape. After that, we'll get into the nitty-gritty of designing and deploying these networks. And finally, we'll look at how automation is just completely changing the game. All right, first up, let's talk about the Internet of Things, or IoT. This isn't some futuristic sci-fi concept anymore, right? It is a sprawling, very real thing that's reshaping just about every corner of our lives, from our living rooms to our most critical infrastructure. And it really all starts in our own homes. Your smart speaker, that video doorbell, maybe even a connected fridge. They're not just standalone gadgets anymore. No, they're all nodes in your own personal network, all working together to hopefully make our daily lives just a little bit easier. Now, this very same intelligence is making our workplaces way more efficient. IoT sensors can optimize the lighting and the heating, they can monitor how meeting rooms are actually being used, and ultimately, they help businesses cut costs and operate more sustainably. And if we zoom out to a much grander scale, IoT is really the engine that's powering the whole idea of a smart city. We're talking about managing public transport, improving how safety services are delivered, and even monitoring air and water quality to create healthier places for all of us to live. And, maybe the most personal application is how it's transforming healthcare. Patient monitoring systems can alert hospital staff to changes in vital signs in real time. And at the same time, all those personal wearables we have are tracking our health, which effectively makes the human body itself just another connected object in a network. Kind of wild when you think about it. And this is where you start to see the true, mind-boggling scale of IoT. It's not just one thing. It's literally transforming every single industry. It could be a drone monitoring crops in a field, an RFID tag tracking inventory in a warehouse, or just your phone unlocking a hotel room door. The principle underneath it all is exactly the same. We're embedding intelligence and connectivity into everything, creating this vast, incredibly complex ecosystem. So this massive expansion brings up a huge and, frankly, kind of scary question. When you have billions of devices, everything from smart locks to medical sensors, all connected to the internet, how on earth do you secure all of it? Let's tackle that next. So how do we secure billions of devices? Well, it's definitely not about playing whack-a-mole with every new threat that pops up. It's about building on a solid foundation. Let's take a look at the core principles, kind of the rules of the road that guide all wireless security. So how does security pros even begin to wrap their heads around this? Well, it turns out they use this really simple but incredibly powerful framework, CIA. Confidentiality is pretty simple. It's about keeping secrets secret. Integrity means making absolutely sure that nothing's been changed or tampered with. And availability means the system is actually online and working when you need it. If you lose any one of these three, your whole security model just falls apart. Okay, so how do we actually keep data confidential? Well, there are two main ways. With symmetric encryption, we both use the exact same secret key to lock and unlock a message. It's super fast. The challenge, of course, is how do you share that key securely in the first place? And that is where asymmetric encryption comes in. It uses a really clever pair of keys, a public one that anyone can use to lock the message, and a private one that only you have for unlocking it. It's a bit slower, but it's much, much safer for establishing that initial trust. All right, so once a device or a user proves who they are, that's authentication, the very next step is authorization. And this is all about deciding what they are allowed to do. The guiding principles here are need to know and least privilege. You only grant the absolute bare minimum access required for someone to do their job. No more, no less. And this matrix is basically how we put those rules into practice. It's just a simple grid that defines exactly who can do what. Take a look at user 3. They can unlock the door, but they have zero access to the thermostat. That is the least privilege principle in action. They have precisely the access they need and nothing more. A simple tool like this prevents accidental changes, and it really limits the damage an attacker can do if an account ever gets compromised. Okay, with those security principles locked in, let's shift gears.
how do we take all these ideas and actually build robust, reliable wireless networks out in the real world? Well, it all comes down to having a structured process.
This quote from H. James Harrington perfectly sets the stage. You can't just guess your way to a good network design. The entire process has to be built on measurement, understanding, and a cycle of continuous improvement.
And a fantastic methodology for this is something called the Deming cycle. It's a simple 4-step loop. You plan the solution, you do the installation, you check to see if it actually meets your goals, and then you act on what you've learned to make improvements. It's this constant cycle that ensures your network evolves and just gets better and better over time.
So, the really crucial point here is that a successful deployment depends on disciplined execution. You have to stick to the plan, you have to use the right gear, and you have to validate your work with post-installation surveys. And please, document everything. Any shortcuts you take here will only lead to massive headaches down the road.
All right, we've covered the what, the why, and the how. Now let's look at the future, using code to manage, monitor, and automate these increasingly complex networks. And this is where things get really, really powerful.
So the magic key that unlocks all of network automation is the API, which stands for Application Programming Interface. And the waiter analogy here is absolutely perfect. You don't need to know how the kitchen works, right? You just place your order, your request with the waiter, and they handle all the complex stuff in the background to bring you back what you asked for. APIs let us do the exact same thing, but with network devices.
And these APIs are part of a much bigger shift in how applications are being built. We're moving away from these old-school monolithic designs, one giant tangled block of code, to modern microservices. For networks, this means you can upgrade or change one little service, like your authentication system, without having to rebuild the entire management platform from scratch. It's a game changer. Now, for all these different services to talk to each other, they need a common language, and that's where these data formats come in. You'll often see JSON used for quick, simple API requests. It's very web-friendly. XML is a bit older and more rigid. You'll find it in a lot of big enterprise systems. And YAML has become a huge favorite for automation tools because it's just so clean and easy for humans to write configuration files in.
This quote from Bill Gates really gets to the heart of why we automate. It's not just about doing things faster for the sake of it. It's about taking an operation that's already well run and then amplifying its effectiveness, making the whole system smarter and way more responsive. And the benefits here are just huge. Automation cuts down on all those repetitive tasks, which reduces costs and frees up engineers to work on bigger problems. It eliminates human error, which leads to much more reliable networks, and it enables the creation of systems that can actually monitor, heal, and even improve themselves over time.
So when you combine all of that, the cost savings, the reduced errors, and these self-healing capabilities, it leads to a pretty fascinating question. As these tools become even more powerful, are we actually building toward a future where the network can essentially manage itself? That really is the ultimate promise of automation, and it's a powerful thought to end on.